guys, now that we're starting our quadratic unit, we want to learn about the key features of parabolas. If you can think back to our very first unit of algebra, you may recall that a parabola is that U-shaped figure where sometimes it's opening up, as you can see in this example on the screen, or sometimes it's opening down, similar to the example that I'm drawing in the top right-hand corner. Now, in order to be successful in our quadratic unit, we need to be familiar with the key features of parabolas. That way we're able to identify some really important features of these quadratics. I'm going to be going a little bit out of order compared to where each of these boxes are, but the first thing that I want to talk about is an absolute minimum or an absolute maximum. As I mentioned, sometimes our parabolas open up, sometimes they open down, and that's kind of what helps determine whether there's an absolute maximum or an absolute minimum. And it is just what it sounds like. An absolute minimum is the absolute lowest spot on a parabola, kind of like in our example here on the notes. It has a lowest point before it starts increasing again. That means it's an absolute minimum. But in the example that I drew, you'll see that this one, if I trace it from left to right, it actually has an absolute maximum. It has a highest point, and then it starts decreasing. Now, that absolute minimum, absolute maximum has a name, and I'm in the bottom right-hand corner now. That name, it's called a vertex. And the vertex refers to either the maximum or the minimum. In this example on the notes page, it's what we're also calling a minimum because our parabola is opening up and it represents the lowest point of the parabola. On the other hand, if we had a parabola that was opening down, that would be called the maximum. Our vertex would be called a maximum. Now, when we're representing a vertex, it's represented as an ordered pair. So you're identifying the absolute minimum or absolute maximum point, and you're writing down the ordered pair. So looking in this example, the absolute minimum is located at -1, 4. So our vertex of this parabola is -1, 4. The next thing that we want to learn about is what we call the axis of symmetry. So I'm going to come up here in the top left-hand corner, the axis of symmetry. Now, the axis of symmetry is a vertical line. And if it's a vertical line, that means it has a slope that is undefined. The axis of symmetry is a line with an undefined slope that goes through the center of our parabola. Now, it's a vertical line splitting the parabola in half. And most importantly, it's a vertical line going through the parabola at the vertex. You'll notice here we have our vertical line cutting our parabola in half, and it perfectly goes through the vertex of our parabola. So your axis of symmetry and your vertex are related, okay? Now, it's a line with an undefined slope that goes through the center of the parabola, making it symmetrical on both sides because it's perfectly cutting your parabola in half. Whenever you're representing the axis of symmetry, it's going to be represented as an equation. But if you recall, it's a vertical line, and a vertical line is a line that goes through the x-axis. Therefore, when you're writing the equation of that line, it's going to be using the form x equals. And it's x equals whatever the x value is on the x-axis that it's going through. So when we're looking at this vertical line, it's going through -1 on the x-axis. So our axis of symmetry is at x is equal to -1. And now I'm going to go back to our vertex and point out that our x value of our vertex was also -1. Again, they're related. Okay, so once you identify your vertex, the axis of symmetry is just x equals the x value from your vertex. All right, we've learned about vertex. We've learned about axis of symmetry. Next, let's talk about our intercepts. The first one that we're going to talk about is our y-intercept. We're familiar with y-intercepts. It's just where the equation crosses through the y-axis. So following this parabola, I see it crosses through the y-axis at -3. Okay, it's where the parabola crosses the y-axis. And for ours, that's going to be located at 0, -3. So y-intercept's nothing new. We're very familiar with our y-intercept. The next thing that we want to learn about is our x-intercepts. However, there's a few names for x-intercepts whenever we're referring to parabolas or quadratic functions. Okay, so we're going to do x-intercepts. But as I said, they have a few names. Our x-intercepts are also referred to as roots. If you're ever asked to identify the roots, it's referring to x-intercepts. They could also be referred to as solutions. Our x-intercepts are also the solutions to the quadratic function. And finally, it could also be referred to as our zeros. If they ask for zeros, they're asking for x-intercepts. Specifically the x-intercept, not the y-intercept. Okay. And whenever we're representing our x-intercept, we're just representing it as an ordered pair. With a parabola, you have two sides of the vertex. You have two sides, a left side and a right side of your parabola. So you will have two x-intercepts. Looking here, it crosses the x-intercept at -3, 0 and 1, 0. So I would write both of our ordered pairs -3, 0 and 1, 0. The next thing that I want to point out is the relationship between the x-intercepts and the vertex. In axis of symmetry, they're all related. So as I mentioned earlier, if your axis of symmetry cuts your parabola in half, that means it's halfway between your left x-intercept and your right x-intercept, which means the distance away from that axis of symmetry is going to be the same. Let me show you what I mean. Here's our axis of symmetry. To get to my left hand x-intercept, I go 1, 2 spaces. Going back to my axis of symmetry, to get to my right hand x-intercept, I go 1, 2 spaces. So since that axis of symmetry is cutting your parabola in half, the distance from each x-intercept to the axis of symmetry has to be the same. And that's going to help us answer our challenge problem at the bottom left-hand corner. So our challenge problem says, if the axis of symmetry were at x equals 3, and one of the roots is at 6, 0, where would the other root be? So I am going to use this visual that we were provided. I'm going to draw the information that they gave us. So I know the axis of symmetry is at x equals 3. So I'm going to go ahead and I'm going to draw a line at x equals 3. That's going to be my axis of symmetry. Okay. Then it says that we have a root located at 6, 0. In order to identify the location of the other root, all I really have to do is figure out the distance from the axis of symmetry to the root that I know. So going from my axis of symmetry to my root, I see it's 1, 2, 3 spaces to the right. That means my other root is going to have to be the same distance in the opposite direction. So if I go 3 units to the left, that will give me the location of my other root, which you'll notice I landed right on the origin. So our other root is located at 0, 0. Hopefully, this was not something that was real far-fetched. A lot of it's really straightforward, but it's going to be really important that you understand all of these key features. So again, our vertex is that absolute minimum or absolute maximum point, the highest point or the lowest point of the parabola. The axis of symmetry is just x equals the x value of your vertex. Y-intercept is where it crosses the y-axis. Your x-intercept is where it crosses the x-axis, which is also referred to as the roots, the solutions, or the zeros. Please reach out to either myself or Mrs. Howarth if you have any questions on your practice problems, and we can't wait to see you soon.